So question number 7 starts with, the city of Providence has a population density of 9,613.66 people per square mile. The estimated area of Providence is 20.28 square miles. Which of the following would be the best estimate of the population? So I want to start by setting up a relationship here to help me solve this problem. And to do that, I want to remember what population density means. So reminder that our population density is where we're going to take the population of an area or population of a place and divide it by the area of that place. So in the case of this question here, I don't know the population. That's what I'm trying to estimate. So I'm going to leave that just as population. I do, however, know the area of Providence is 20.28 square miles. And that's going to equal 9,613.66. So in order to solve for the population, I'm just going to multiply both sides. I'm going to do an inverse operation here. So if I'm dividing by 20.28, I'm going to multiply both sides of my equation by 20.28. I'm going to multiply this side by 20.28. Right, and I get that my population is 194,965 people. Or question A here. Or sorry, answer A. All right, so question 7 on exceeding our standard here. A farmer determines that every acre of land that is planted, 2,000 pounds of wheat can be produced per year. So our first question asks, how many pounds of wheat can be produced from 1 acre of land in 3 years? And this question is actually kind of almost deceptively easy, right? If 1 acre produces 2,000 pounds in 1 year, in order to figure out how many pounds of wheat will be produced in 3 years, we just need to take that 2,000 pounds from 1 year and multiply it by 3 years. And we'll get that 6,000 pounds of wheat can be produced from 1 acre of land. So part B asks, how many acres of land should the farmer plant in order to produce 8 million pounds of wheat in 3 years? So we're trying to find the number of acres, and we know that 1 acre produces 6,000 pounds in 3 years. All that we have to do here is take our 8 million, that goal amount that the farmer wants to produce, and divide it by 6,000, right? The amount of wheat that 1 acre of land will produce over 3 years. So I already put that in my calculator over here, but we get 8 million divided by 6,000, and we get 1,333.333333. We're going to pretend, though, that this farmer can't plant partial acres. He can only plant full acres. So to make sure that he can plant the entire, like he gets that full 8 million pounds of wheat, we're going to round this up to the nearest whole number and get that he would need 1,334 acres in order to get 8 million pounds of wheat in 3 years. All right, so on to question number 8, where we are finding the area of the rectangle below, rounding to the nearest tenth of a square unit. So if I look down here at my rectangle, I can see that it is plotted on a coordinate grid for me already, which is great because it's going to give me a lot of information about its size and its lengths and its widths. But I also hopefully am noticing that the sides of my rectangle are not vertically or horizontally aligned with my grid. That's really important because it tells me that I can't just count to get the lengths or the widths, right? My distance between point A and B doesn't line up with my grid marks, so there's no way for me to count the units. If I wanted to find this exact distance, I would have to use my distance formula. So that would be one approach, is I could use my distance formula to find the distance between A and B, which I could use as my width, and the distance between B and C, which I could use as my length, multiply those together, and that would give me the area of this rectangle. Alternatively, this is what we really practiced in class, is I could divide this shape into shapes that have horizontal and vertical distances that would let me just count on the grid to find the area. And then once I find the area of all those shapes, I add them together just like any other compound or composite figure. So that's the method I'm going to model here. That's one that I prefer. I think it's a little cleaner than using the distance formula. So if I want to divide my rectangle, which is a kind of parallelogram, into two different shapes, I'm looking right here that if I go from A to C, this is a horizontal distance, and it nicely divides my rectangle into two triangles. So I have one triangle up here, and another triangle down here. So to find the area then, all I need to do is find the area of this triangle, which will be my base times my height divided by 2. My base here is really conveniently just along my x-axis. So I can just count my units. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one got a little covered up as I drew it, but that's 11. So my base is 11 units. Multiply by my height. Remember that our height goes from our base straight up to our vertex of that opposite point, right? That opposite vertex. So I'm going to be a vertical distance of 5 units, right? 1, 2, 3, 4, 5. And that gets divided by 2. So 11 times 5 is 55. We divide 55 by 2, and we get 27.5 square units. Now, really importantly, that is just the area of this first triangle here. To find the area of my second triangle, we do that same thing of base times height divided by 2. So my base is 1, 2, I should notice, right? It's the same as the base above it. So that'll be 11. And my height is actually also going to be the same. So when I divide really nicely along that from A to C, I've divided this into two congruent triangles. And I can show you, right, our height goes from our base straight to our other vertex. So 1, 2, 3, 4, 5. Divided by 2, or multiplied by 1/2. And we get 27.5 square units. So when we add those together, 27.5 plus 27.5, we are going to get 30, nope, not 30. 20 plus 20 is 40. Plus 15, so we get 55 square units here. All right, so again, all I did was I added my first triangle plus my second triangle and got that full area of 55 square units. Okay, moving on to my exceeding standard. I have this really funky looking polygon here. And I'm going to use the exact same method I just did of breaking this into different shapes, using vertical and horizontal distances only. And looking at this, I can kind of see two shapes I know how to find the area of, which is, if I got right here, I have this really nice right triangle. And then up here, I actually have a trapezoid. If I feel a little shaky on the area of a trapezoid, right, I can always divide this even further. I could cut down here, make a right triangle. I have a rectangle, and then I cut here again, and I make another right triangle. I'm going to use just a square or a right triangle and a trapezoid, just because it makes it a little bit faster. But there's nothing wrong with cutting it into more shapes if that makes you more confident. So this area here, again, just a triangle. So my base times my height divided by 2. So my base is going to be 1, 2, 3, 4. And my height is 1, 2, 3. So 4 times 3 is 12. We divide that by 2. And we get 6 square units for our triangle. And then for our trapezoid here, our area, you can look back at question 2 if you want a review of that formula, but it's height. So my height again goes from my base straight up. So this is going to be my height, 1, 2, 3. And that's going to multiply the full quantity of our base 1. I'm going to make this base 1, which is 1, 2, 3, 4, plus base 2, which is this whole length here. So 1, 2, 3, 4, 5, 6, 7, 8. All divided by 2. So 4 plus 8 is 12. I divide that by 2, and we get 6. So we have 3 times 6, which is 18. And to get my full area, all I need to do is add those two together. So I'd have 6 plus 18. We get that our full area is 24 square units. All right, that takes us to the end of our assessment. Hopefully these were really helpful in helping you along with your test corrections. On that Google document, there are also extra resources for practicing each question, including where to look to get notes and classwork to make sure that you really actually truly understand that skill. Again, that's our whole goal, is we are trying to master these concepts. So even if we weren't quite there on this assessment, that's okay as long as we are putting in the work and effort to learn and understand it and then reassess to really show mastery of those skills. And again, feel free to come and ask me any questions about any of these, and I'd be really happy to walk you through.